Okay, it's 10:30. Let's get started. Welcome everyone to the early science session at this year's community workshop. We have an early science session every year. Many of you have been before. Some of you might not have. I'm Leanne Guy. I'm the Associate Director for System Performance in Rubin Operations. You might also know me as the Data Management Scientist from construction. So myself and the team, it's not just going to be me talking today, I'm going to give you a rundown of where we're at with the early science program and what to expect in the coming months to year. I've got to scroll through. Okay. Okay, so we'll start with just a quick introduction to the early science program. I know many of you know this, but in case there are new people here, just to let people know what this is. Then Melissa's going to take us on a walkthrough of Data Preview 1, what we've already achieved. For Keith Bechtel, I will run us through the LSST-CAM OnSky commissioning campaign, what the plans are, what the survey looks like, what data we've collected so far. Eric will then take us on a walk through early alerts, and then we'll come back to have hopefully something of an open discussion around what future data previews and releases might look like based on the commissioning data. Okay, so the Rubin LSST Early Science Program was put in place probably 3-4 years ago in order to try to enable early science by the community with commissioning data and any other data that's of science grade that's released before the start of the survey. We define early science as any science enabled by Rubin for its community through and including the first data release 1, which is based on the first 6 months of data. We have a guiding document, RTN 11. It's currently in version 6.2. This is a living document. As we walk through commissioning and we look at the data that's collected, we reassess what we can do, we reassess what the best scenario is for making that data available to the community, and we update this document. The document covers the data products and the data access environment for early science data. It gives timelines for implementation. It talks about the science considerations and our relationship with the SCOC, and just provides up-to-date information on where we're at with early science releases. This is a citable document. It's on Zenodo. You'll see there's a DOI down here. Please do use this in your proposals. This is our official statement on what you can expect and when, and we hope this can be used to support funding proposals for early science. Oops, wrong way. Okay, so the motivations are basically threefold. It's to enable high-impact science prior to the first data release. Through SV, we're collecting a lot of data which we can do science with, so we want to make that available to the community. It's to provide early access to both static sky and time domain science-ready data products to support the community to prepare and develop their analyses, validate their pipelines in advance of data release 1, so that the community can be as ready as they possibly can be to do science with our first official LSST release. And it's also to enable early time domain astronomy via alert production during commissioning and the first year of operations. There are roughly 4 elements to this program. First, we have a series of data previews, data preview 0, 1, and 2. These are based on either simulated LSST data, that was data preview 0, or Rubin commissioning data with either the commissioning camera or the science camera. That's DP1 and DP2. We delivered DP0, sorry, a few years ago. That is finished. We've just delivered DP1 on the 30th of June. Melissa's going to talk to us in detail about what's in that. And we're now collecting SV data with the science camera and thinking about what DP2 might look like. Template generation prior to the start of survey operations and using LSST-CAM commissioning data and incrementally generated during the first year of operations. Effective template generation is to support the third bullet, which is a world public stream of alerts. Alerts are based on difference image analysis. Difference image analysis requires templates, so we need to build up the templates before we can do any sort of alert distribution or alert production. And this effective template generation is to try to maximize the number of templates we get early using commissioning data and using year 1 data to try to ramp up that stream of alerts before the start of the survey. And then the first data release 1, which was planned to be based on the first 6 months of LSST data. This is our timeline at the moment. We're roughly here at the community workshop. We're about a month into the science validation surveys. We've had first light back in July. We're a month in. We've got, that's roughly a total period of about 12 weeks. We'll have this engineering shutdown for 4 weeks before we hand over to operations. Sometime during commissioning, we want to start sending alerts out to community brokers. After we start operations, sometime after that, we will start the LSST. We will start the processing for DP2, release DP2 roughly 9 months after we move into operation, and we will incrementally stream up the live alert stream. And at some later point during year 1, the prompt products database would also become available. Oops, this is not logical. The data product delivery schedule also changes as we move through this early science program. We cannot deliver everything immediately, so we have this ramped up delivery of data products. For data preview 0, you can see that we only delivered a mix. We only delivered some data products with each of the data previews, but for all the DP0s, we covered most of the data products except for cell-based coads and shear object catalog. DP1, we were able to deliver all different types of data products except for cell-based coads and the shear object catalog. We expect to do the same with DP2, and we have the co-added images and shear object catalog as a stretch goal for DP2. That is still TBD. And then once we get into the first year of data taking, we expect to be routinely delivering all the data products, data product types. Any questions? Okay. I'm Melissa. Yes, I can do the first slide. Okay, the first slide here, data preview 1. We delivered this on the 30th of June. It's our first preview of data from Rubin Observatory based on a reprocessing of science-grade data collected during the LSST ComCam on Sky Science Pipeline's commissioning phase of that commissioning period. There are 1,792 science-grade exposures collected over 48 distinct nights from late October through to the 11th of December last year. The data, these exposures are distributed across 7 roughly equally sized non-contiguous fields, spanning a range of stellar densities, latitudes, and overlapping with external reference data sets. The total area is about 15 square degrees. The release contains about 2.3 million distinct astrophysical objects. The total release itself, images, catalogs, is about 3.5 terabytes in size, and it is available to data rights holders via an early version of the cloud-based Rubin Science platform. If you go to data.lsst.cloud, you'll be able to access this if you're a data rights holder. This here to the left shows you the paper. The paper is in preparation. We are almost finished with this and almost ready to submit it to the journal. You can see this paper though at rtn95.lsst.io. It's also a tech node, and if you want to see what's in that paper, use it to try to support your science, you're welcome to take a look at the pre-submission version. Just bear in mind that it's still a little bit in flux. Okay, Melissa?
Okay, I'm just going to tell you a little bit about what's in DP1. If you were in the DP1 data access session yesterday, you probably saw most of these slides, because all of this content is just made straight from the documentation and tutorials. So you can find everything that I'm about to say at dp1.lsst.io. And I just put that link in the Slack channel chat as well. What are we doing? Okay. So first off, data preview 1 only includes data that was taken with the LSST commissioning camera. That's LSST ComCam. Does not include any data that was taken with LSST science camera. Does not include the data that you saw in the Rubin First Look media event. ComCam is small. It's just a single raft of 9 CCDs, and it was only on the telescope for 2 months in late 2024. And during that time, the observing was not continuous, but it was still pretty substantial. And that's the data that made data preview 1. So while ComCam was on in late 2024, it covered 7 fields, and they are the little yellow fields that you see here on the sky. So you can see right away that some of them are closer to the galactic plane, and that there are some deep fields, and that 47 Tech was also covered. This is just a table that has each of those 7 fields and the number of visits, where a visit is 1 observation at a given time in a given filter. That's at 30 seconds. Of the sky, the number of visits per filter, and the number of visits total per field. The takeaway points that every field got G and R, 3 of the fields got all 6 filters, and that ECDFS, the Extended Chandra Deep Field South, was the deepest observed field. The point of this is I'm trying to help you pick which field you would use if you wanted to do some DP1 analysis. This is a table for every field that was observed, the total number of epochs, where that's the total number of nights, and then the average number of visits per epoch. And the point here is that, again, it's the extended Chandra Deep Field South that had the most epochs. And then after that, it's the low galactic latitude field and the Euclid Deep Field South. So if you want to do time domain studies with DP1, you pick those fields to do your studies with. This is an image that is just a depth map of each of the 7 fields. So ECDFS, extended Chandra, is the top right field that you can see there is the deepest. They're all on the same scale. And you can notice things like 47 Tuck, it's a globular cluster, it's extremely dense. And that's why it looks like there's a hole in the middle. Doesn't look like it. There is a hole in the middle of that one. So it's very challenging to process in the crowded fields. All of these are the depth maps in RBAN. This is a table, it's again for each of the 7 fields. And this one summarizes and compares the 7 DP1 fields. And it's also available in our tutorial notebook 301.0, that's the DP1 overview, where all of these other tables came from also. And the point of this one is just, again, trying to give a bit of scientific direction for which field would you use for which type of analysis that you're going to go in and test with DP1. So this particular table has a suggested science use column, and it also has, I think, an incomplete, but at least a list there of some external data sets that overlap each of the fields. So very common things that people ask us for. So we made this as a table for you. So overall, the kind of takeaway message is that DP1, Data Preview 1, it's small, but it is a very complete preview. And by complete, I mean that it has lots of science-ready data products. Pretty much, I don't know if I can say every, but most of the types and formats of data products that will come with DP2 and DR1, little versions exist in DP1 to help you test and plan. So it's science-ready data products in the same format as future data releases, all available in the same mechanism for access and analysis, which is the Rubin Science Platform, as you will also use in the future. So that's what I mean by small but complete. And the second takeaway message about DP1 is that, like I mentioned, it met all the stretch goals and really exceeded expectations. And that was because it was truly a full team effort to get all those stretch goals met and to make a very useful first data preview for the science community. Just want to point out, make one final point about Data Preview 1, especially if you were with us for Data Preview 0, that all of our tutorials, which people consistently report as like the single most useful aspect of all the resources that we provide to accompany our data releases, the tutorials are the most useful. Everyone loves the tutorials. For Data Preview 1, we did a complete redesign. So we now have tutorials at 3 levels, where the 100 level is all how-to. They're short how-to, they're focused on RSP functionality, and they, as the title suggests, they show you how to do one single thing. We have 200 level tutorials now, and each of those tutorials focuses on a single data product. So those are the tutorials that are really good for reference when you're like, yeah, I need to use visit images, but I forget how to get them. You go to the 200 level tutorial that's for the visit images, and it shows you what's in them and how to get them. And then we have the 300 level science demonstrations. These are all longer tutorials that execute some kind of end-to-end workflow that show how to do some kind of analysis or scientific topic that kind of combine everything that you would have learned in the 100 and 200 levels and then applied it. I want to make the point that development is still ongoing. For the portal aspect, we have about 22 done of our 30 that we wanted to have done for DP1. The notebook, we have almost 60. Actually, we do now have 60 done of the about 90 that we had planned, compared to for DP0, I think we only had about 18 tutorials total. So this was very ambitious redesign to try and make all the tutorials more helpful, because we know it's what everybody likes. And then API, we kind of only need one. It just shows you how to make a token and connect from whatever third-party API tool that you're using. I think, yeah, oh, right, how to get the tutorials. This just shows you, for example, when you're logged into the Rubin Science Platform, the Rubin Science Platform development team made a new tutorial delivery mechanism, which we like very much. So now there's just a menu item that says tutorials, and you click on it, you select your data release, DP1, you're confronted with the, do you want a 100, 200, or 300 level tutorial? Select from that list. This particular example has selected the 300 level. You get another drop-down menu that has a bunch of what we call them series. Series 301 is our field explorations. So maybe you select that one and you'll get, and now the 301 series there's the overview notebook that I mentioned before, which is where all those tables came from that helps you explore the data preview one and what is in it. And then there's one tutorial per field. So now that you've learned a little bit about the DP1 fields and you know how to get a notebook, you can go and get started just by whichever field you thought sounded most interesting to you. Go and grab the tutorial for that field and you're up and running with Data Preview 1. So hopefully just a lot easier for people to get started. And I think I did not make this slide. Yeah.
Sorry. Okay, this is just the final slide, I think, of this section on DP1, and then we'll pause to take questions, see if Melissa, and questions from Melissa. So I want to also highlight that as part of this early science program, we don't just incrementally roll out the data products and the data as it comes by. We are also incrementally rolling out our services to access that data. And the Rubin Science Platform is that service. And what we have deployed at the moment on data.lsst.cloud, this is exactly the platform that Melissa just showed you, where you can go to get all these tutorials. This is an early version of the Rubin Science Platform. So not all the functionality that we expect to deliver to access the survey data is currently available. We first rolled out a preview of this on the Google Cloud in 2022 to support Data Preview 0. Since then, we've added many new services to the DP1 version. This is still running in the Google Cloud, although you shouldn't see that at all as you access this interface. I think a key point here is that although DP1 is comparable, or it's actually smaller in size than existing survey data sets, it's only 3.5 terabytes. Many people have said, well, okay, I could just download that. You won't be able to just download DP2 or data release 1 or 2 moving forwards. And so what we wanted to do with DP1 was to make it available through the same tools and services that you will have to use to work with DP2 and future releases, so that you can start to get used to working with these on a smaller data set. And just a point that the RSP remains under active development. Incremental improvements are coming out all the time. In fact, as they mature, they're not necessarily tied to a data release. And so as you work with this, if you find issues, please use the community forum to start discussions on this, and just bear in mind that it's still an early version of the science platform. Okay, we'll just pause there now and see if there's any questions for Melissa on DP1 before we move on. There's one, thanks.
Hi, thank you. Actually, maybe it is about the science platform. So if that's okay, sorry.
Of course.
You said we cannot download data going forward after DP1. How true is that? If we wanted to download 10 terabytes of data, would we be allowed?
What I'm saying is that you can't just download the entire release, and the whole release itself will be too big to do that. I'm not saying you can't download plots or things that you make, or
what?
Sorry.
No. Am I allowed to?
Okay, no, we will throttle you if you try to download the whole lot out of the science platform, okay? What we do is have a number of independent data access centers set up, and we will coordinate data transfer to those data access centers. So NERSC, for example, is one, and has Data Preview 1 been transferred already? It has, okay. So the project work with NERSC to transfer the whole of Data Preview 1 to NERSC to make it available on their resources to the NERSC, the community who have access to NERSC. Likewise, there are data access centers. There are a number of independent data access centers, what is something about 8 or 9, something like that, around the world, who are also preparing to take the entire release and have that available to serve to their community.
Okay, so if I was interested in downloading, say, the co-added images, I should go to one of these other places, is what you're saying.
I'm not even sure what they're planning for. Just to be really clear, the big issue here is if everyone wants to download all the data, we'll end up paying for it. We don't have the resources to pay for the egress fees from the cloud. So that's the main throttle that will happen here. We have some cushion, and some people will download some data, but at some point we'll have to throttle it because we can't afford to pay for all the egress. Now, as we learn and we distribute data to different places, I expect some of this will be able to improve that situation. But as Leanne was saying, right now, there's just the concept of a bulk download to support specific IDACs or processing centers.
Okay, thanks.
Okay, any other questions? All right, so let's move on. Okay, I'm going to talk about the OnSky commissioning campaign with LSSTCam now. Keith Bechtel was going to give this, but he was unfortunately not able to join us, so I'm going to give these slides on his behalf. And I think Keith is online. He can pipe in whenever he wants.
I'm here in case there's questions.
Hi, thanks, Keith. Okay, so the OnSky commissioning campaign with LSST has begun. We've been running for about a month now. It is targeting a certain set of fields. It has been working to commission the AOS and to collect data for science verification and validation. It also was used to support the first look and to collect the first look targeted observations. The fields that have been chosen to do the science verification and validation span a range of science themes. There's a number here listed here. They cover part of the Virgo galaxy centered on M49. We have some extreme density stellar fields with extended nebulosity, so the Trifid Lagoon that you've seen already. We have low ecliptic latitude fields at high galactic latitude. The deep drilling field Cosmos has already been observed. New Horizons is also one of our fields for testing difference imaging in crowded fields. And we also have some moderate stellar density fields as part of this program. So there's a wide range of targets, a wide range of characteristics as part of the plan. So all the OnSky commissioning activities are being run by the feature-based scheduler. As we run through them, we're going to sort of conclude at the end with a set of science validation surveys and a full operations rehearsals that will run over 30-odd days. This will cover specific targets that are visible during the June to September period. It will focus a lot on overall operational efficiency of the entire integrated system. Guidance from the community has been used to develop the cadence that we use to observe. We've also worked with the SCOC to develop the baseline survey not the baseline survey, sorry, the survey that's being run as part of the science validation surveys. Yeah, so basically this is what's being executed at the moment. We're slowly progressing and moving through this. We modified the SV survey design a while ago to try to incorporate concepts from the standard LSST cadence to validate the survey strategy. This was in discussion with the community. And we've been running these pilot observations since the 20th of June. We're now routinely collecting full nights, hundreds of images, hundreds of observations or exposures every night. I think I probably just said most of this, so I'll move on from that. Okay, this shows you the SV survey design specifically, the design concepts. This image here shows you exactly what's part of it. It basically has two components that are implemented in the feature-based schedule and executed autonomously. The deep survey is optimized for testing deep coads at the equivalent integrated exposure of the LSST 10-year survey depth and beyond that. They have a rapid temporal sampling in those fields, and they're used for validating the observing strategy for the deep drilling fields. And you can see those deep drilling yellow dots across the map there. The wide survey, you can see that the stripe is optimized for testing template generation and prompt processing with the difference image analysis at data rates that we would expect during the first year of the survey. And this also provides us with a sustained test of the whole facility, the operation of the telescope, the transfer of data, and the processing at the USDF. And so this is what we're executing at the moment. This shows you the density of sampling in the deep drilling fields. On this map here, the x-axis is time. This is per night. Each here is the different deep drilling fields, and the colors represent the filters. The DDFs during SV use a modified form of the ocean strategy. This is currently being considered by the SCOC. It features more frequent observing epochs to better sample night to night time domain phenomena and to provide distinct epochs for validating our internal calibration. The LSST, the XMM LSSS, this is the bottom one here, is designated for a deep season. You can see it has longer sequences of visits in each epoch, particularly in the I and the Z bands. This here shows you the number of observations that we expect in each of the fields here. In the wide survey, this shows you the wide survey in each of the different bands, the simulations, and the median number of expected visits. This is comparable to the LSST year one in the wide component. It's implemented using a configuration that is similar to the wide, fast, deep in year one, but is constrained to a region of plus or minus 10 degrees about the ecliptic. By concentrating observations in this region, it's possible for us to build up several hundred degrees of template coverage in multiple bands prior to starting the LSST. This allows us to begin testing prompt processing with difference image analysis and also supports alerts in year one. And this shows you how our template coverage is expanding during the SV surveys. We have increasing template coverage throughout this period to test the prompt processing. Here's a number of nights in the survey and the area with possible templates in each band as we move through that. Survey progress to date. There are 2 links up here. You can go to these links and have a look at the weekly summaries and the nightly reports. This shows you where we're at in the survey. You can visually see how we are progressing through these SV surveys. To the right here, this plot shows you cumulative number of visits. The blue is the simulation and the orange is the actual. So we're actually staying quite close to the simulation. We've got something like about 10,000 visits collected so far. And this shows you the coverage in each of the bands where we are so far. So the next steps in commissioning. The on-sky commissioning campaign will conclude in mid-September, and this will allow us a period of 1 month for pre-operations engineering and maintenance. That was indicated also in the timeline slide that I showed at the beginning. Our SV surveys are being conducted during winter in Chile, where the environmental conditions are not as optimal for on-sky observing. Our delivered image quality is varied between nights within a given night and across the focal plane for individual visits. The median delivered image quality that we're getting during these SV surveys is not yet reaching our goals for the 10-year LSST survey. Basically, Rubin Observatory is still in commissioning. Our top priority is construction closeout and taking observations needed for the ongoing system optimization and to commission the observatory. This might imply a reduced duty cycle for the SV surveys between now and mid-September. So the primary goal of these SV surveys is commissioning, it is construction, and it is to do science verification and validation for the construction project. The early science program is obviously opportunistic on this and tries to find synergies wherever possible. Bob covered this yesterday. I think we've also started preparing for targeted opportunity observations, where we've developed a set of procedures and workflows and test plans to demonstrate the capability to perform TOO observations during the on-sky commissioning period. This includes prioritization of event types, making decision trees for triggering on TOO observations, the technical capability to receive alerts from other telescopes, to do image processing, and our observing strategy for template generation, etc. We have successfully tested some of these aspects, and I think Bob reported yesterday at the SAC on some of the observations that we've taken in TO. So this work is going well. And so just finally on this, what are the SV survey connections to the early science program? The SV survey data is, as I've just said, primarily supports construction completeness, but also serves as the basis of several components of the early science program. So the current plan is that all science grade data collected during commissioning will be reprocessed into Data Preview 2. The public alert stream, subject to approval once it's begun, will ramp up through the commissioning period, also based on this data, and into year one. And template generation during commissioning will use the data collected during the SV surveys to incrementally generate templates over the maximal sky area that's supported and use those observations as we move into year one of the survey. Okay, so before we move on to more details about the early alerts, are there any questions on that? There are three questions. And Keith, are you online? Because you might be better placed to answer some of these than me.
Yeah, I'm listening.
Hi, Samuel Wyatt, NASA Goddard. You mentioned that there's these nightly reports or just weekly summaries. What level of data is provided there and potentially is it programmatically available? like just observational metadata where you looked for how long and in what filters?
It's summary data of what happened during the night. There's metadata, there's information about the visits, the number of visits aggregated over the number of bands. There's information about air mass, there's information about seeing the progress of the schedule, how are we progressing through as compared to the plan.
And there are rumors of an OBSLOC tab, like an IVOA compatible just schedule that will be released nightly.
There, yes.
What level is that being prepared, or is it prepared yet? Is it
OBSLOC
available?
TAP is coming. The rumors are correct. There will be one. It is coming. We will be announcing during the survey, we will announce the survey planned observations in advance of taking those observations, and you will be able to get the history of observations. It's not yet, it's also one of our services that's currently under development.
Great. And lastly, for the TOO testing, how disruptive are y'all testing and simulating that? Is it going to be like nightly? Like if an alert goes off in the middle of the night, like a gravitational wave event, will it be able to be observed that night?
I might hand that over to Keith or Bob.
Thank you.
So we have a target of opportunity advisory board, and we receive alerts, and we have configured the scheduler configuration for the science validation survey such that it can be interrupted, and we've demonstrated that functionality several times at this point. So we basically consider commissioning the capability to take the TOO observations as it's part of commissioning, it's part of our operational workflows. So we are exercising that capability now.
Bob wants to add something.
Thanks, Keith. I'll just add that we've planned through the detailed cadence of the survey for about 3% of the time. So this committee will be really important in choosing the right alerts to go for.
Michael Strauss here. I just wanted to, you showed that about 20% of the SV survey is currently complete. We're told that mid-September, the SV survey will end. Does the remaining 80% fit within the between now and mid-September in practice?
I'll let Keith answer that.
Yeah, I mean, so you could see on the chart that that was up a few moments ago that we are close, basically pretty close to holding pace with what we had predicted in the simulations. We have now many nights where we have acquired over 700 visits in the same night. It's becoming pretty steady state and pretty routine. What we're trying to optimize right now is the delivered image quality is one of our primary metrics. We have a distribution of the delivered image quality, and it's not yet achieving our goals for LSST. So we are considering options to dedicate a little bit more time for continued optimization of the AOS and other aspects of the delivered image quality. We also have periods when the weather is not conducive, and if we lose several nights of dark time during the finite period of the SV surveys, that could set us back. So I think what I would say is that from a technical capability standpoint, we're pretty close to being holding pace, but I wouldn't be surprised if the final volume of delivered data from the SV surveys was a little bit less than the simulations, both because of weather that is outside of our control, as well as strategic decisions to basically spend more time optimizing the system performance.
Gautam? Thanks.
Related to Michael's question about the comment about the median SV image quality not being yet at the LSST 10-year level, main survey level, do we have some sort of quantitative assessment about how far off we are? Because a lot of this discussion about augmenting the SV surveys is also going to be effectively informed by, is it currently worth adding 2 months of data, or is it worth just...
Exactly, yes.
So
Yeah.
is there like a plot of, median PSF full width half maximum or something for the SV data? And
Yeah.
Yeah, I was planning to show more quantitative information about that on the dedicated commissioning session on Thursday. And there's also two sessions that are specifically about the image quality that are scheduled for Thursday as well. One way to think about it is what we have been able to show is that over the SV surveys, we have been maintaining a system contribution to the delivered image quality at the level of about 0.6 arc seconds, averaged over periods of a week or more. The target for LSST 10-year survey is to get that at 0.4 arc seconds or below. That would be added in quadrature approximately with the atmosphere contribution. And so what it means is that the delivered image quality is, probably, a few tenths of an arc second worse than what we would be seeking for the LSST 10-year survey. But there's variability within nights across the focal plane on individual visits. So there's a distribution. I'll show details on Thursday.
Maybe you just add something about how the early science program works with that. You're absolutely right. The delivered image quality and the quality of the data at the end of the SV survey does impact what would be the optimal choice to make for moving forwards in terms of what goes into DP2. We work closely with Keith, we track this, and this is part of our constant updating of what the early science program is and why we keep an open dialogue about it. Renee?
Just to take that point further, like these discussions are fantastic, but I wonder if then, I don't know, a call in a month from now would be good, or a month from then, so that we don't set in stone something now that will happen in October when we'll know a lot more about SV. Okay.
Yep, that's absolutely. We're not going to set something in stone. We can make the best plan we can make now. We do have to plan in advance for some things, but we do also have to be flexible enough to pivot if things aren't as we expect them to be. So yeah, good idea. Another question? I'll leave it there then.
For DP1 or in future DP2, do you include source catalog and it's from different images? Catalog. Yeah.
Yeah, the source catalog from difference images is in DP1, and we fully expect to in DP2. If we've delivered a data product in DP1, we expect to be able to continue delivering that data product. Okay, if there are no other questions, I'll pass over to Eric Belm, who's going to walk us through how we're planning to ramp up early alerts. So you've got to push your fingers up like that.
All right. Thanks, Leanne. So I'm going to speak about our progress towards early alerts. Yeah, all right. So I guess the thing to start with is, this session is talking, we've talked a lot about prospects for early science, but I think it's worth emphasizing that early science has already begun. Many of you have seen or are co-authors on this nice paper led by Colin Chandler, showing some Rubin observations of the 3I interstellar comet. And so I think this really highlights for us that the data are capable of enabling that early science already. And so the alert stream in particular is the way we want to sort of start this discovery process and make it publicly available. All right, so some time ago, we wrote a document, because we always write documents in Rubin, that sort of went through a list of what we thought we needed to do before we could start distributing alerts publicly to the brokers. And so in particular, we needed some approvals from our funding agencies. We need the pipelines to be ready. We need templates. We need to archive the alerts that we're sending. We want to make our catalogs available through the PPDB, or the Prompt Products Database, which is queryable by data rights holders. We want the images that we're processing to be available to users, again, through the RSP for our data rights holders. And of course, we have to document and characterize performance. So as we sit today, some of these have increased in priority, and some of them we are descoping, descope is way too strong, are not prepared at the moment. Sorry, gotta be careful. I just caused a bunch of heart attacks. No, sorry. I apologize. Oh my goodness. All right. Goodness. We're still waiting for the agency approvals, and that fundamentally is the fundamental blocker that we can't send alerts until we receive that. We expect it relatively soon, but we're still in that process. We also have some items I'll talk about on the pipeline side that we want to get done before we start distributing alerts. We are learning more about template generation, incremental template generation. There's still a lot to do there, but we think we have a broad handle on that. And the alert archive is generally in good shape. We don't expect this calendar year to have the prompt products database or the prompt images available for sort of technical reasons. And so the project is considering going ahead and distributing alerts to the brokers, even without those sort of additional services being available. Obviously, that makes some degree of detailed analysis more challenging, but we think that our broker partners can still enable a great deal of real-time science even without those. We are in the process of building a documentation site like the one for DP1 that will contain a great deal of information that users of alerts will want to have. And it will also contain sort of performance estimates of false positive rates and so on that will be useful for scientists as they work with these data. All right, I think DP1, of course, as you heard, contains different images and different images catalogs. I think the broad picture that we found from looking at those data is that they broadly are ready to support early science. There are certainly questions and issues we're chasing down, some of which you'll hear about in the science pipeline session right after lunch today. These are a couple of plots by Bruno Sanchez from the AP team that are in the DP1 paper, RTN 95, showing that we're getting very good completeness on injected point sources. And the plot on the right is showing the astrometric residuals of the matched injection sources, showing a 0.02 arcsecond spread of the brighter sources there. So we think that we're getting good completeness and accurate measurements in difference imaging. This is just a difference image. I picked literally the first one I pulled up from DP1. So you can see that cosmetically it's quite clean. You do see bright stars that are sort of missubtracted, and that was, I would say, the dominant source of false positives in DP1 and in LSST-CAM relates to detections around brighter high signal to noise stars. That's something we have a few ideas about how to mitigate, but that's the biggest thing to watch out for. But I don't think is a blocker for most science. We have a machine learned reliability model, again described in the DP1 paper. You'll hear again from Tatiana Cerro-Gular, and this, it says Wednesday, I apologize, it's today, the next session. So it performs very well on transients and asteroids. We didn't have variable stars in the injected training set, and so it doesn't perform very well. It tends to mark variable stars as bogus, even though they're not necessarily. So that's a known issue. Gautam doesn't care. Some of us want to discover variable objects, and we will. So we have plans for updating and retraining this model on LSST-CAM data, and so anticipate that not being an issue going forward. You just heard about some of the progress of the science validation surveys. This is a plot of the same data with a relatively generous cut on the image quality of the constituent images, so a 1.2 arcsecond cut. For image differencing, we really prefer to have good seeing images in the template. And so in the sort of small fields that we are observing early in commissioning with LSST-CAM, we have lots of data and can make good templates. We're still sort of right at that sort of marginal edge on the broad SV survey in terms of having enough images that we'd really like to sort of put a template into production. I am hopeful that over the next couple of weeks that we'll get just that little bit more data that will let us be ready. And certainly as the deep drilling fields are coming up, those will be great candidates as well. On the pipeline side, we again have a relatively short punch list that we're trying to work through in the next few weeks. We are updating the alert schemas to reflect what is implemented and what is ready, put in a couple of wish list items that have been conveyed to us from brokers and other users. We are making sure that we are including the appropriate records in the alert packet for associated solar system objects. We have implemented a flag and an algorithmic approach to look for what glints from rotating space junk. This is something that has been seen in ZTF and other surveys, and we also see it in our data. So we want to be able to identify those. We have an algorithm and a flag now, and so we're going to filter those out so they won't reach you. And then there's a technical issue that the shutter motion across the focal plane means that the effective time of individual sources varies, and so we need to make sure we include that effect. So these are the sort of things that the pipelines team is going to work on in the very short order. Oops, that was not what I wanted. All right, and then there are the class of things that we will continue working on even as we're sending potentially alerts out publicly. The ML reliability model update is going to be something that's going to take some time to accumulate enough labels and do the retraining. There are challenging areas in image subtraction. Crowded fields still need optimization. I talked about bright star issues. We want to be faster. We want to make sure we fully characterize the performance, and then kind of continue the sort of gradual ramp that Leanne was describing. So the take-home message is that alerts are coming. We're going to try to get those to the brokers as soon as we can. I think the brokers also need time to commission and get their systems ready. So we'll sort of work together to sort of make sure that we're ready for science use. And I think in general, the message here is that I think the data do support science, but we are commissioning. So we're not aiming for 60 seconds right away. Things may go down. We may have false positives, but I think that it will be really valuable to have community eyes on this data and allow us to find and fix things faster. So looking forward to some discoveries coming from the alert stream, I hope very soon.
Do we have any questions for Eric, either in the room or online? Where's Christine? There's a couple back there.
You mentioned technical problems that are limiting the ability to get out the PPDB. Can you elaborate a bit more what those problems are?
Sure. There's two databases that are relevant here. There's something called the APDB, the Alert Production Database, which is a large Cassandra system that is optimized so that the pipelines can retrieve that 12-month history that goes into the alerts. And that is not a user-facing system. It can't support general queries or it's very focused on connection with the pipelines. And so we have this model where the APDB is listening to the pipelines, recording new information, and then we export that data to this user-facing prompt products database. And the team recognized it's been kind of a concern for some time. The team recognized that the technical solution we had that we had baselined wasn't really going to scale to the expected user demand and the scale of the data. And so what we're exploring right now is using Google BigQuery to host the PPDB. And so we're working actively on doing that export from APDB to PPDB, understanding it's a commercial service, understanding the cost profile, understanding what it looks like under query, And so that is active work that's ongoing, but it's not done today.
Hey, Eric, really exciting. Thank you. You mentioned some issues with the subtraction in crowded fields and around bright stars. Have you looked at some nearby galaxies like M87, say, to see how the subtractions are around big nearby galaxies?
A little bit. Johnny Estevez in the commissioning team has done a little bit of analysis. I don't have a take-home message for you right now. I think this is something we're still looking at. Seems like we're almost more complete than we should be. So we're not losing stuff.
Hi, Eric. Thanks for the update. So you mentioned this Gleam Trail flag to filter alerts out from the stream. How many filters are you applying, and what are those filters?
You mean in general across?
Yeah.
Okay.
So what filters are you using to filter out alerts from the stream?
Yeah, great question. Let me see if I can reconstruct, and we're happy to sit with you afterwards if it's helpful. We reject on a subset of pixel flags that are essentially always junk. So if the core 3x3 pixels of a dia source, for instance, are all marked as saturated or no data, that's obviously not astrophysical. We reject things like that. We're going to we're planning to do something subtle with the glint flag specifically. We're going to reject sources that that have a glint flag but are not dia objects already. So if it would create a new dia object, and it's in a line of dia sources, we're going to say this is probably not astrophysical and get rid of it. But if there already is a dia object there, we will keep it. We'll send it, but you'll have that flag to say we're not sure, right? There's a few other things I'd have to sit down and think. I'm afraid I'm not pulling it up all on the fly, but happy to walk through. It's all, again, open source. I can show you where to look in the code.
Okay, thank you.
Eric, I wanted to ask about when alerts are coming. You sort of said soon. Can you give a sense of like weeks, September-ish? When should we be thinking about this? Like, I'm not expecting it's going to be tomorrow, but can you sort of give a tilde and sort of time frame a little bit as best you can? I know that it is obviously, a moving target because commissioning is the telescope's being commissioned. There's things that have to take priority, but can you give a sense of like, is this 2 weeks, 3 weeks, a month? In that kind of time frame?
Yeah. The short answer is I can't, because until the agencies say yes to us, we're stuck, and I don't have insight into where that process is right at the moment. I think on the pipeline side, I think we have a couple more weeks on those sort of blockers that I identified. We're working fast. It's exciting to have a finite punch list that we can say, these are the things left that we think we have to do. And we're still talking to the brokers to understand their needs and when they feel like they're going to be ready. We haven't been able to send real LSST-CAM alerts to them yet because it's all data has had to stay at the USDF. And so, we're having a conversation with them about, when they feel like they'll be ready. So, it's not this week. It's not next week. I would like us to be as soon as possible.
Eric, there's an interaction between the alert stream and the PPDB access, particularly in year one when we don't have a full data release catalog yet, and brokers are going to want to query probably the PPDB to get things like what's the galaxy at the location of this alert, if that's not in the alert packet itself. Is there some sense on when we can get both PPDB plus the alert stream going, which is really the full alert system for time domain, or if those two are really just completely disjoint processes, is there some way for both the science collaborations and the brokers to work with the alert production team to stand up small services or get a few additional data products made that will help process the alert stream in a way that's useful for the community.
I'm puzzled by the statement that the brokers want to query the PPDB for Galaxy information.
If it's not in the alert.
So everything, the only thing that's in the PPDB that's not in alerts is some of the force photometry that hasn't made it yet. So otherwise we're sending you the full record. So to the extent that we have associations of galaxies or others, they will be in the alert. To the broader question of broker partnership and so on, I mean, I know many of the brokers have database facilities that would be, that enable this, and that is a fantastic resource for the community. It's not something we have control over, obviously, as a project.
Have satellites been an issue for alerts or otherwise? There was a lot of concern about them at one point.
I'm sorry, could you repeat that question?
Have satellites been a problem for alerts or otherwise? There was a great deal of concern about them at one point.
Yeah, I mean, we have a sort of multifaceted set of tools that allow us to try to remove satellites from alerts, and I don't anticipate significant contamination. Hi, Igor.
Hey, Eric. I'm curious if you could expand a bit more about what the content of the alert will be in terms of real bogus discrimination. I think also thanks to DP1, we're learning a lot about what the products look like. There are some values that work maybe better for some science cases, less for other. So I was wondering if besides the reliability key that you mentioned, there is something else that will be added in this sense. And also something you mentioned to me offline is a good way to give feedback in general and interact with the team's community. Just wonder if maybe it could be useful also for others to know what are the preferred channels so that we as a community can help you in the process.
Great question, and thank you, Igor. Yes, anywhere in community, the community science team is fantastic at monitoring that and feeds questions to us that many of them they answer directly, and sometimes they work back to us. There is an alerts and brokers channel that's public there, but I would say wherever folks feel like their question fits is fantastic. To your question about reliability, again, we have an existing model that we'll be updating. I think the existing model is already sufficient to enable some science for sure. We'll be updating that. I can't give you a super quantitative statement right at the moment about if you're asking like what is the false positive rate of LSST CAM. I think I don't have that number in a way that I am happy to report right now, but it'll be part of our training process. Will let us assess that. So look for that performance characterization in the next month or two.
Hi, Eric. I have a question about the cutout sizes. Is there a maximum size for them? And if so, does it depend on the box size field of the alerts? I ask because that can be very large.
Yes. As you know, the base cutouts are relatively small, sort of 30 by 30 pixels is the minimum. We can make them bigger if the detected object is bigger. I think I don't have a firm sense of the upper limit at the moment, although it doesn't make sense to make them too much larger than the longest streak that you'd expect to see from something astrophysical. So, as you know, as the cutouts get bigger and bigger, the data rate to the brokers gets larger and larger too. So we have to be a little cautious of sending, really enormous cutouts.
Okay, thanks. Just to that point and Igor's point before, and maybe I'm getting a little bit confused, but so the brokers will be giving a real bogus score, but you can imagine having that information earlier would help you not have a bunch of extra DI objects that are essentially we know that they're in the end, they have a low score. So is there a way to potentially work with the brokers to do some sort of loop so that you're not actually giving out as many alerts to the brokers in the end, if you include that score as a criterion to cut on?
Yeah, that's a great question, Renee. Thank you. We have the capability certainly to filter alerts on the reliability score to throw out things that we think are probably junk. And I would say we have not taken a decision to do that either in the short term or the long term. It's probably wise for us to start with that just because it's better to sort of let the brokers sort of have a fairly pure beginning. But the model has always been that we would like users to be able to make their own cuts, right? To say, I'm willing to push more in the noise. This is, this sort of object is important to me, et cetera. So I would really like in the long term to avoid introducing that selection effect if we can. I see Fed, and maybe Fed, do you want to just comment here directly?
No, that I think I agree with you. But perhaps I'm missing something. Would it be hard for the brokers to only select based? I mean, they have that info, right?
Yes.
So a broker could make the choice, receive all the alerts, and make the choice of making a cut. And different brokers could make a choice of making different cuts, which might actually help us understanding more. More of the alerts that we get. Am I missing something?
I don't know. Gautam just made a painful face. Maybe we should take this offline. I don't know. Leanne, do we? Okay. All right. Okay.
Sorry,
Okay.
just to say that I think, like we get the alerts. We should distribute it. I think they should be in the Word in some form. So I would prefer if Rubin delivered all the alerts.
I guess my take is, at least during this early science period, the people who best know about the image quality from the telescope is the project. You know all about the issues with, M1, M3 thermal stability, AOS, whatnot. You have the best sense of how the Rayleigh-Bogus score maps onto image quality. If you simply say, here is a floating point number, brokers, please make a cut, you're going to get something considerably less suboptimal than if project just makes a reasonable choice. And I think the community would be perfectly happy with a smaller but still pretty pure alert stream with whatever the best possible image quality that the survey can deliver at any given time is. And you guys can make that choice. It'll get better with time. There'll still be so many alerts we have to do science with that no one's going to complain at you.
David Trilling, I see both sides of that. I just want to point out that we have a lot of things that somebody else might think is bogus that we see as very scientifically interesting.
Yeah.
Not to say that Gautam is wrong, but we have to be careful not to throw away too many things because then we're missing interesting science.
Yeah, to be super explicit, like, the worry is about comets, active asteroids, extended things, fuzzy things that might trip Rayleigh-Bogus.
Correct. And we have lots of experience of seeing that those things get low Rayleigh-Bogus scores, but they are scientifically interesting.
I would say there's an outstanding task. Colin has given us some known objects that we can assess what the scores are now and see how it's doing, and that would be at least informative.
Yeah, David said the first part of what I was going to say, but the second part is I think this is actually easy to solve. The project can just give a recommended cut.
Okay.
All right, thank you. We can continue this discussion afterwards if there's time. I just want to move on to the next topic, which is also quite important. Okay, scenario for future science data releases. So we're coming back to data release processing now. We've put DP1 out. We learned a lot from doing DP1, and now we want to look at what we want to do in the future. This is our current early science schedule. Most of the top lines we've completed already. We're sort of coming up to first alerts and then the start of operations in October, then the start of the survey shortly after that. And then data preview 2 is scheduled sort of It was originally scheduled for early March to May 2026, but in fact, we know now that it's going to take us longer to do that. And our current estimate is more like July to August 2026 to do DP2 based on just the SV data. Then not long after that, we've got data release 1, which was scheduled for late 2026. We clearly wouldn't make that target either. And then data release 2 in future. All this together with ramping up the alert production and the prompt products database that Eric has just talked to us about. This is a lot of work and it's a highly aggressive schedule. And I'm going to invite Colin up to talk to us in a little bit more detail about some of the challenges posed by this release schedule.
Okay, so as Leanne was describing, our hope was that the data previews were very useful for the community to be able to understand how to work with the LSST data. And on the project side, we found that those data previews, the process of producing them and distributing them and making them available, has taught us a lot about what it takes in order to make that happen and the amount of effort and work that goes into those, the production of those data releases. And so based on what we've learned from doing that for the past few releases, we've come to the conclusion that the existing plan that had us going straight from data preview 2 to a data release based on 6 months of LSST survey data, and then immediately needing to turn that around in 6 months in order to be to make time to start processing the next release, is just infeasibly aggressive. So for most of the survey, the plan is to do a data release annually, at which point we would have, which means that we'd have 12 months in order to go through the process of starting from scratch, processing all the data, making it available in the science platform, all the things that we need to do to make it usable. This first data release that was in the schedule nominally for since basically the start of construction had that squeezed down to 6 months. And that's just very difficult to meet for really what's going to be our first processing of a large scale data. So this is a big increase over the data preview 2. So there's a lot of processing to do in a very, very short time frame. And you can kind of see here, I've highlighted when we need to be doing processing in order to meet these release deadlines. There's really no margin in between data preview 2, the 6-month data release, the 1-year data release processing. And that both means that it's very difficult for us to it's both challenging for us to meet those deadlines, but it also means that there's no time frame to get feedback from the community in order to take what you've learned from the most recent data release and be able to incorporate that into this 1-year data release, which we expect to be sort of the most valuable one to the community starting the survey. So, okay. So we've been involved in many discussions, both with the Science Advisory Committee, yesterday with the Science Collaboration Chairs, with the external reviews last week. And our proposal is to focus instead on data preview 2, which will come out next year, and then focus immediately on the 1-year data release without trying to do the 6-month data release in the middle. We think this means that this gives more time and a better opportunity to make the most of data preview 2, to make sure that that is really of high quality, high value to the science community. This gives us breathing room in between data preview 2 and the start of the first full data release to really get all the algorithms that we want to be ready for that data release, tuned up, adjusted, really gives us time to focus on making that high quality release without simultaneously having developer resources and attention diverted into another simultaneous processing that will be happening at the same time that we're trying to get ready for processing the 1-year release. And I think this both gives us a better chance of ensuring that those are high quality, and also give us a better schedule margin to make sure that we really can accomplish this. And then we're not trying to overpromise and then we're rushing to push out a data release that might end up being subpar just because we need to have it out the door to be ready to start working on the 1-year data release. So this is I think where we're headed. This is a little bit more detail, sort of the similar points that I said. This means that our focus really is on a high quality data preview 2 and a 1-year data release. We believe that many of the goals that we had for this 6-month data release at the start of construction, that the goal really was to get data out to the science community as soon as possible. We're really trying to accomplish that with the data preview program right now. We think that that's already doing a good job of that. So we think that we're meeting the goals of that release, but just the realities of getting that produced means that it'd be better to focus on DP2 and a 1-year data release. And I think this is going back to Leanne to talk about options.
Thank you, Colin, for that walkthrough of the challenges that we face on project. This slide is meant to stimulate discussion. Please don't take this as something any sort of law I'm laying down. It's based on discussions we've had so far with the science collaboration chairs, with the SAC. And so now I think what we want to think about are options for DP2. How do we make DP2 maximally useful to the scientific community given that we're not going to have a 6-month data release? So I'll just run through these 3 options for discussion. The first is that we base DP2 on the LSST CAM commissioning SV data and all science grade data as already planned. And we start the LSST survey in October as planned, immediately after or very soon after the engineering work, and we enter operations. We start preparation of data preview 2 in late September, and we deliver DP2 somewhere in the July to September timeframe, and we deliver a year 1 data release 1 in the October 27 to February 28 timeframe. This is essentially the sort of plan at the moment. We start the LSST shortly after we get into operations. The second is very similar. We still start the LSST shortly after we move into operations and the engineering work is concluded, but we hold off on DP2 and we include the first 2 months of the LSST data in the data preview 2 release. This means we wouldn't start full preparation of DP2 until January 2026 after we've collected all that data. So then this will push DP2 out by 2 to 3 months. So we would expect a DP2 in October to December 2025. This would not affect the start of the LSST though, because we have still started the LSST when we thought we would. So we would still expect to deliver a DR1 in the October 27 to February 28 timeframe. So DP2 would be 3 months later as compared to the first option, but DR1 would roughly be on the same schedule, maybe plus or minus a month or so. And the third one that has also been discussed is that we take additional targeted observations targeted around certain fields specific to enabling the maximum of science with DP2 to supplement the SV data. We do this for a maximum of 2 months during the November and December periods late this year in 2025. This means again that DP2 preparation doesn't start until January 2026. We would deliver DP2 in October to December of 2025 as per option 2, but DR1 will now be delayed because if we delay the start of the survey, we delay the delivery of the first year data release 1, and this now wouldn't come till say something like January 28 to April 28. So DP2 is 3 months later than option 1, and DR1 is 3 months or more later with respect to option 1. Just to maybe demonstrate this is option 2. Lynn Jones did a couple of quick simulations of what this might look like. These are just rough simulations that we quickly did to try to illustrate this. So if we start the LSST with the new version 5 baseline and include the first 2 months of data in DP2, this is the sort of area that we might expect to cover. After 2 months within the low dust, wide, fast, deep area, the median number of visits over about 11,000 square degrees might be, as you see in the table here, covering all these bands. Just note that the DDFs in this image are saturated on this map, but they would naturally be included as part of the release. And then another option for a specialized survey, this is just an example. I'm not trying to suggest any particular type of survey. So if we spend up to 2 months collecting additional data over a narrow area to year 1 depth, so example of 60 days where the area is aimed at the low dust extinction wide, fast, deep area, covering say 17,000 square degrees, you would have median number of pointings here and co-added depth shown there. And I think that's the last of my slides. So this was really meant to stimulate discussion. And so I want to just open the floor up now to comment. Christine, who's Christine with the, yeah, Bob might want to, and Colin might want to help as well.
Hi, this is Kate Napier with Slack and Reuben. On what time frame would the modified, on what time frame would a decision be made about modifying the data releases? And will we get a vote on options 1, 2, and 3?
So yes, there is a typo. I'm sorry, there is a typo at the end. It's not 20. It should say 2026. I'm sorry. There's a typo in there. No, calm down. Eric and I can take the prize for the best blunders. Sorry, it's 2026, not 2025. Okay. We want to continue to track the progress of the SV surveys to see how they do. That's obviously, this is a point brought up by, I think it was Gautam or Rene just before. So that's obviously an input to this to see how we do with the SV surveys, to monitor that. Maybe it will turn out that one of these becomes an obvious choice. So the idea is to work with the science collaborations, especially for option 3, to ask, if we did do a targeted survey, what would you want? And we can simulate some of those in advance, and we can provide some quantitative information on that. We can make the decision to do this, broadly speaking, just before we start doing the LSST. We load the survey into the scheduler and we execute it. The key thing is the first 2 are easy. We already know what the baseline survey is. If we decide to go with either one of those, we simply start executing the survey. We can even wait till a bit later to decide what goes into DP2, but we don't want to put that off, because if we're going to do a DP2 based on option 1, we want to start that processing as soon as possible to push it out the door. It's really option 3 where I think we'd want the science collaborations to think about what they want. We'd work with the science collaboration chairs to ask them what they want, if they want to go with this, and we try to simulate that. So lots more hands are going up. I don't know how to. I don't know how to do
Meg Schwalm, Queen's University, Belfast, wearing my hat as a Solar System Science Collaboration co-chair. I guess I first want to stress the point that we as a community have been waiting with a schedule, and we have been planning our science and how to work with year 1 based on what was available. And so we are seeing a new schedule, but the sense is to me that this is minimum times that we can estimate delays, right?
Yes.
So I think my concern is, right, that we need to know before the start of the LSST, as soon as possible, what's going on so we can plan, because people are writing proposals, people are planning sabbaticals, have been trying to get ready for year 1. And my concern is especially about understanding this uncertainty. I, as a community member, worry that we don't have till November, when the nominal start of LSST is, to decide this. This needs to happen as soon as possible, in us understanding the state of whether the observatory is ready to be handed over to operations. Yeah. With that, the question that I want to ask is that, right, in terms of how these options are here, is there any potential for sort of what is it, I guess, in terms of what's the minimum amount that can be added to a processing that we can understand that wouldn't delay the data releases or the data preview?
Which data release do you mean?
Both of them. Okay. Because the concern is that one science area may need some data and may want 2 months, but that also then will hurt somebody else who needs the data, actually needs the data preview. And so trying to understand the trade-offs would be really helpful if we can understand what is the minimum amount of observations we can add that won't add a potential of a 2 or 3 month shift into data preview.
So you're saying, for example, if we added a week of observations, would that not impact the schedule?
Or 2 weeks or 3 weeks, right? Like, can we get some understanding? Because it's not clear to me, or maybe it was clear in maybe the SAC meeting, of what is causing the delays, to understand how we make these trade-offs. And so maybe you can talk about that, of what do you think, or if anyone from our commissioning can talk to, what is it that we think we can augment that would get us the data to the community as soon as possible, but enable those people in the community that need to have that additional data, so we get the best compromise and maximize distributing the happiness to everybody, right? And that's my worry, is that I don't have a sense for that. So maybe that's
before we
something
move
can
to
comment on.
Renee, just let me very quickly say one thing. Remember, we have this 1 month downtime of engineering time. So if we do take augmented observations in November and December and add them to DP2, we've that month is sort of, we're not going to do nothing. We're going to obviously be looking at the data and doing a lot of processing. But if we wait and take any data, even 1 week, 2 week, 3 week, we've still got that whole month to get through. So if we go with option 1, we start processing DP2 very soon, and that will get you DP2 based on SV data as soon as possible. I'll just add that. I'll let Renee speak.
So thank you. This is actually kind of related to that. So there's 3A, option 3A, which is not
Okay.
on your slides,
All right.
which is that, for example, if, we've been talking a lot about the Cosmos field, it would be really great to have that. It only rises late. So one could imagine, well, one who's not involved in the show.
One who is Renee.
One who is me, could imagine, you start LSST, but then, you move to the Cosmos field kind of in January, you do a lot of observations there. That, of course, is not technically in DP, but would you be able to include that without a huge delay, similar to Meg's question?
Include Cosmos in DP2?
In DP2.
We have to wait till we collect the data in January. We have to process the data. We have to go through the whole process of making a release. So it sort of falls into 3 in that if we wait until January, that delays the whole of releasing DP2. But if we do start the survey as per the survey, it shouldn't really delay the year 1 data release 1 by, I don't know, by much. I want to let Colin say something.
Simplest answer is that it would be the delay of however long it took us to get to observing Cosmos. But because Cosmos is like its own particular thing, we could maybe think about ways, but we can't commit to anything right off the bat. Like we need.
Nothing's Renee, nothing's
I'm not
impossible,
saying
but
it's
there are
impossible,
trade-offs.
But I'm also not saying it's not impossible.
Yeah. So, I mean, to everybody, I think the most important thing in the next few weeks and months is to hear your input of what you think you would need to do science. But then we're going to have to assess that and make the technical decisions. So no one here today is going to be able to tell you if any particular thing is possible. Some things, but you get what I'm saying, right? I mean, we really want to hear your input now, and then we're going to have to work with you to make the final decision, but we can't tell you what's exactly possible today.
Just to that point, I totally agree with you. And we're looking for the things that can maximize science, but understanding that our priority, all of the science collaboration's priority, is that LSST is great and works. And like that, of course, comes first. And we understand that you're heavily constrained. It's almost like I want to turn that back to you, Bob, and say, like, we're excited about SV and extensions and whatever, but that's partly because we're imagining SV is as good as LSST data will be. And it's obviously not going to be like that because it's not, that's not the point. So the more quantitative data we can have about how it's going will really help us make recommendations for what we can do with any extensions should they happen.
So as I think someone mentioned before, go to the commissioning section. I think it was Keith, go to the commissioning section. You'll get a detailed overview of where we're at now. Go to those 2 links that I showed you that show the progress of the survey. You'll find more information there. But I absolutely agree with you. Yeah.
So actually, irrespective of which option ends up happening for DP2, it's still the case that there is now just a very large gap between DP2 data release and DR1. And in that time, there is nobody from the science collaborations really sort of having a look at the data while you folks are working on it, producing it, and giving you sort of continuous feedback. Now, right now, until the end of DP2, the Sitcom in-kind teams are playing that role, but they go away after DP2 is out. And I would like to strongly advocate for continuing them as sort of people, a subset of people that can be updated potentially, but that can have access to preliminary data products while your team is producing them so that they can give you running feedback and make sure that DR1 is actually of a good enough quality that the science collaborations will be happy with it. Without that, I worry that we're just going to have like a 1.5 year gap, and suddenly we're going to get data from Ruben, and then people in the science collaborations are going to turn around and say, this isn't what I asked for.
So we definitely want to get feedback from the community. That's a good point. We want to look at ways to enable that. I'll just say it won't be sort of a total gap because we're ramping up the nightly data products. We'll get the prompt products and the images, and you will have all that data to work with, and you will have DP2 to work with. And we'll be constantly working to take that feedback on board. We can we can talk about other ways that we can maybe enable early community feedback during processing.
I'll just start saying I support what Gautam just suggested, and there's been building up of people with expertise in the commissioning in kind, and I think there's opportunities to take advantage. I recognize some of the political and science and data things about that, but I still think, as Gautam says, you could find a group of people who like that's gonna be okay. My two questions were, so what is the process to gather this information? And if that process doesn't exist, who is the group that will determine that process this next week to do this, to list the pros and cons and have that information? And thank you very much for putting together these three options. That is very helpful and helped sort of focus from yesterday into these
They're
things.
not meant to be exclusive. I'm
No,
not pushing
no, but-
anything. It's meant to
but-
stimulate discussion.
But it's important to be specific enough so we agree on what we're talking about and all that. And just for my own personal vote, I say keep it simple, keep it one, focus on getting the stuff out.
I
But
like
my
how you
other
think,
points were more
Michael.
important.
I have Meg wants to say something, and then we've got. Oh yes. So Meg, and then there's a question here, and then there's a question back there. Oh, and then Chris. Melissa, do you want to say something about how we're taking feedback on DP2? Do you want to know? Do you want us? Oh, and how we're going? Yeah. Oh, so you mean to make this decision? I thought you meant on feedback on the. So I'm sorry, I misunderstood it. Yeah.
Well, we will take an action to develop a way to get the feedback. It will almost certainly involve the science collaboration chairs and our close meeting with them over time. But we'll take that action. We will make it known as soon as we can, very soon.
Thanks.
So it's a comment / question that I wanted to raise that I think to emphasize Leanne's point is that prompt processing is the way, right? It is the same stuff running, and that the transit community, the solar system community need to be ready to go. I know solar system is, we can dive in. We're going to find the edge cases, the outliers, so that we're like, hey, that looks wonky, so that we can then get the best data release. And so it's going to be right, and that it's going to be this balance of if we take lots of data at the beginning that are not that, well, then we've delayed being able to dive in to do that. And so I just want to emphasize that point of prompt products is that, you know, put us in, coach. We're on the bench ready to go.
No pressure,
Like,
Eric.
that is the community that can help those that really need that the data releases to be perfect, because we're going to spot that. And so I think we do need to balance that component of getting that ready to go. And as seeing alerts are coming, just to highlight that. So just wanted to emphasize that point as well as a positive of
Right. Thank you.
alerts are coming and we're going to be able
Yeah,
to.
thank
look at
you.
those.
Over here.
For transient, really, we need find the target as soon as possible. This is just photometry, as you know. We need to follow up and we need to get extra photometry. So I don't know what's the goal of LST, but eventually we want models like GTF. A few days later, we got all targets of the transient, so we can sort out many telescope in the world that identify.
So you mean follow up to other telescopes?
Right. So
Yeah.
we need really not, this is one old, I mean, I understand during the commission stage, but eventually we need just a few days.
Yeah, I
We
mean, I think
lose
that's more
the
appropriate to
forever.
the alerts and the prompt products is more, I think you're talking more, do you want to, no. Yeah, you're talking, I think you're speaking more there to the alerts and the prompt products and what Eric was talking about getting the alerts out. And we are certainly going to be putting a lot of effort into ramping up the alert stream and enabling that as soon as possible.
Will alert be before the data DR release schedule?
Yes, as Eric was saying, we're waiting on agency approval. It's hard for us to say anything at the moment, but we're hoping in the next few months we would start sending first alerts. Basically, as soon as we're able to, modulo the constraints that Eric described of agency approval and doing some work on the pipelines. Yes, first alerts will certainly come before DP2. There'll be a big problem if they don't. We'll have other problems if that's not the case. I'm not sure what order. I think it was you, and then I think Chris, and then Rachel.
Hi, thank you. I'm a normie, not deep into LSST. So the
Normie.
advantage of number one is that it lets me get some data, work on it a little bit before the NSF AAG deadline in November 2026. And those other options do not let me do that.
They do not.
So for like a normie like me, if I want to do science with LSST, number one lets me do it a year before the others do.
Number one does minimize complexity. And at this early stage of commissioning where we're doing these things for the first time, we're putting the whole system together for the first time. Minimizing complexity there's a lot to say for minimizing complexity, I think. Chris?
Sorry, this is a slightly complicated question. So, okay, so this is related to giving feedback, which Gautam mentioned, and also sort of related to this idea of that people who are doing prompt processing could see that data and give you some feedback. So this is about static science. So in another context, this came up at the desk meeting, and when I asked, I got very different answers from different people. Nobody really knew the answer. So the question is, before DP2 comes out, nobody can see DP2. Everybody sees it at the same time. But what is the policy for looking at the raw images? And downloading those images. So we have, the expertise to run some of those algorithms ourselves, for example, in the desk. So we could be checking how things are working by taking a subset of those raw images and doing stuff at NERSC.
Do you mean raw or process visit images? I presume you mean post instrument signature removal.
Either.
Yeah.
But I always thought my memory of this from all the discussions we had was that after the embargo period, the raw images, the calyx that came off the camera would be available. But some people from the project at desk meeting said that was not true.
These are the nightly images being available after 80 hours.
Yeah.
Yeah.
So can you sort of tell us what that policy is? Because that's conceivably a way for us also to do some checks. I agree with actually Gautam's idea is better, which is to extend.
So we're working on the services to make that available. At some point, nightly images will become available after 80 hours. But we don't have the infrastructure and services in place to enable that yet.
In principle, we'll be able to see.
Yes.
Okay.
We don't expect that the services to be deployed till something like mid next year. I think it is. Gregory might know more about that timeline, but I think mid next year is roughly the infrastructure and services to support access to nightly image data products.
We haven't settled on a final date for that, but I would say like the first half of the year.
He said the first half of next year. I'm being more pessimistic and saying the middle of next year. Where's the next question? Rachel,
Here.
yes.
So I want to point out two concerns with option 3.
Okay.
One is that the taking additional targeted data into November and December effectively rules out any of those targeted fields being pretty much anywhere in the galactic plane, which sidelines a fair chunk of TVS science. The other concern I would like to raise is more about human resources. 2 months or delaying data releases by 2 months, 3 months, if you have tenure, maybe that doesn't sound too long. But if you're on soft money, that can be serious delay.
Yeah.
And this is for a project that has been pushed back due to pandemic for perfectly good reasons, but anyone who had a finite grant to try and do early science with LSST is now being pushed to the end of that program at a time when getting further funding is extremely difficult. So I would like to push back on the grounds of human resources about making such a decision casually.
Yeah, that's a great point. Thank you, Rachel, about funding proposals. And we're not going to make this decision casually. We are going to engage in a lot of conversation with the science collaboration chairs, but it's a great point about funding and availability, which also I think argues for minimizing complexity and getting the early data out as soon as possible to support those people in that situation, which to me supports getting you a DP2 as soon as possible. We're at 12 o'clock. I'm happy to hang around, but you're all welcome to leave. If anyone has more questions, I'm available for chatting. Thanks, everyone. And thanks to all the speakers.